Well, good morning, everyone. This is tracked as specific for the vendors, which I think is a great opportunity to get to a little bit deeper dive into some of these conversations. Our first presentation this morning is for these folks from Dewberry. This is James Parker and Kim Pearson, and they'll be talking about using ArcGIS Enterprise to expedite asset inspections and exceed client expectations. I was talking with Kim a little bit about how sometimes customers ask for a little bit more that stretches us sometimes as vendors to learn better processes and do better. So I will let them introduce themselves and get right into the presentation.
All righty.
James.
Welcome. Thanks for the people that I ushered into the room at the last minute there. Thanks for coming in. Click. Got no love from the remote here. Oh. Okay, good. Do you want to go first?
Sure. So my name is Kim Pearson. I am a department manager within Dewberry, and my group focuses on asset management. So we are completely geared toward helping our clients understand what they own, when they need to replace it, planning for the future. You can see I have a bunch of other random certifications on there, and I work out of Raleigh, North Carolina.
Morning all, I'm James. I'm a GIS guy and a project manager. I'm also the product owner of our geospatial platform. So we use that to help deliver projects and serve up spatial data and applications. And I am based in the DC area, just to the south.
So today we're going to talk about Campbell University and a project that we did trying to help them. They had a new facility director come on board. They realized they had no idea not only what they owned, but what the building conditions were, or anything that was happening, especially with maintenance because of COVID and having had a reduction in staffing. So we ended up coming on, and we were supposed to assess every mechanical, electrical, plumbing, structural, and architectural system across their entire campus, which is actually their main campus, their healthcare campus, as well as a Raleigh Law School campus. So they wanted to focus on the next 10 years, everything that they needed to do, and make sure they had a solid capital plan so they could work on funding and planning. It ended up being 67 buildings. There were 2 that they don't actually own, but we still assessed for them, and it was over 1.7 million square feet. And they needed all of this done by the end of the year so that they could start planning for their budget for this next coming school year. So originally, when we do these projects, we used to do them by hand. So engineers would go in the field, they might have cameras, blueprints, they might have a spreadsheet that they're like just writing stuff into, but everything was done by hand in the field. The engineer would then come back and sit down with one of our data managers, and they would put everything into different software platforms to really capture what the system were, their condition, and then plan for when they needed to be replaced, as well as what that replacement cost would look like. So it was a very time-intensive process. We also knew that there were some times we would miss things in the field, and we would have to go back and do a second trip, because maybe we took a photo, but we didn't document where that was, we didn't write anything down. So this was a very labor-intensive process. And then with Campbell, we knew that this wasn't going to work. We needed to get through all of their resident halls in a 2-week period before students came back, and we needed to get through the rest of the building by roughly the end of September in order to even get close to meeting our deadline. So we had to have an internal discussion of how do we make this work, how can this happen, and knowing some of the things that we have within Dewberry, I reached out to James and said, okay, we need some help. What can we do here to speed up this process?
All right, so onto the GIS pieces. Dimensional view is the name of our geospatial platform that I mentioned. It's really before I get into this, Dewberry, we are an engineering firm. We design bridges and build all kinds of interesting things. We also have a very big geospatial division, and we're famous for LiDAR and remote sensing work, airborne data collection. We're also very capable on the GIS side of things, so solutions, analytics, software, And this is an example of capabilities we have on that side. So Dimensional View is our brand name for our geospatial platform. You can read more at dimensionalview.com if you choose to. We essentially host data, build applications, and deliver projects for our own internal stuff and for our customers. And it's really a mixture of bits and pieces. A large part of it is ArcGIS Enterprise, most of the things you'll see today. We use Postgres databases. We use some Vertigis or GeoCortex reporting pieces, FME for data, ETL and movement. And we write code and build custom extensions and widgets along the way. So it all runs on the AWS cloud, so cloud ready. And we're often asked, why Enterprise, ArcGIS Enterprise, or we use ArcGIS Online, what's the difference? And when we kind of when we provide this platform in this way, you get the best of both worlds, in my opinion. So I'll share some more about that in a moment. So I realised this had a pointer, which is great. Here's the architecture that we'll talk about today for the Campbell project. And there's 4 pieces. Over on the left, we use Survey 123. So that can be, surveys can be submitted in a browser on any device, or you can use the nice applications on Android or iOS. But ultimately, data is sent in via web services and arrives into the Dimensional View environment, which is orange box around the edge is the Amazon cloud piece. And within there, ArcGIS Enterprise, great big popular GIS platform, and we use that to publish our web services and share maps, manage users and groups and those good things. And beneath it, we use this geodatabase, SDE-enabled geodatabase to store the data. Feature classes, the related photographs, attachments, all goes into this database. Part 3 is the fun bit that the users interact with. So we have our kind of a hybrid application that shows progress and data and metrics coming in throughout the collection process. And then really the last piece at the end of the project is about export, format, and delivery to other systems. So I have a quick video here. I don't know if I need to, oh no, good, it's already playing. So this is the UI that I showed. The top piece is a banner with branding and different tabs for things users need to see. We have anything orange on the page relates to systems inspections, and anything blue relates to another type of inspection requirements inspections. We have metrics and submissions per user. If you can see, Kim wasn't really pulling her weight. She's in here in kind of 3rd, 4th place. And obviously a big map component in the middle. I'm about to search for one of our 50 buildings, a batting facility, and doing typical GIS things, changing base maps. I can verify, I'm no expert, I think this is a baseball field, and the batting facility is right next to it. If I choose to now, I can switch to my requirements layers, orange, as you'd expect. And I think I'm about to make a selection over here on this building. So we had 11 different requirements. Surveys go in. I can see details and timings and users, and of course the photographs that were taken at the time. I don't know what this is. I think it's a fuse box.
It's electrical panel.
Okay. So rich information coming from the field and showing up in real time to the office team here. If they choose to, you can just view the tabular view here and export based on selection. So again, all kind of typical GIS things you'd expect, but really easy to put together and quick to share. And then I think lastly, if I were a QCer and I needed to update a record, maybe I found an error, maybe someone had misspelled aluminium and they'd forgotten to put the I in aluminium. That's a joke. You could correct it, hit save, and data is edited for everybody who's viewing it. So really that's it. In the interest of time, I won't go through the Survey 123 piece, but if you click another tab, surveys surveys are there. Okay. So I'm just going to go through those 4 main parts of the architecture and hopefully share some interesting technical pieces that may inspire. So we have 2 types of survey form, like I mentioned, surveys and requirements. We use Survey 123 Connect. It's something you install on your laptop, and really you configure how the survey looks and feels and the answers and things you can format in Excel, Microsoft Excel. And when you're happy, you save and you republish, and your users get nice formatted surveys to submit. Usually, when you publish surveys, they end up as a hosted layer on your enterprise platform. We always migrate our stuff into the database. There's a few good reasons to do that. We have a bit more control. You can connect directly to it. Other useful things with the surveys, you can control whether it's, like I said, formats, submission types, buttons. You can show and hide different questions based on previous selections. You can even calculate values, in our case, like expected lifespan of an asset. So the survey piece was very important and kind of the first part of the system here. If we were to make any enhancements, we probably would. Our 2 surveys need to know about each other. So a new system is entered. The requirements surveys need to be able to pick up that new survey name, that new system name. So one for the next time we do that, we kind of have some ideas about how that would work. And then if you've worked with photos and related things, they go in as blobs in the database. We've got some ideas about putting those on in places where it's easier to view them. Okay, part 2, geodatabase. If there's any DBAs in the room or database people, they'll know that we like to, as I said, we like to manage stuff in real relational databases rather than the hosted. We can do things and tell our customers that we're doing these things, backups every night for 30 days. We can encrypt columns and data if there's any addresses or names. Integrate with other systems. Maybe you've got Power BI and you want it to read from the database. It's a bit easier to do over here. So we actually introduced a trigger. If anyone's familiar with this term, it's essentially for us when a new survey record came in, we have a trigger, so something in the database that says, all right, got a new record. I'm going to go and look up by the building name. I'm going to get the correct polygon shape, and I'm going to join that onto the survey. When we're inside the buildings, the GPS isn't so good, so we, instead of collecting the coordinate, we go grab the building outline. And you might ask, well, why don't you just use relationships between buildings and submissions? Maybe, but for this case, we wanted the polygons every time, and it worked for us. So, part 3, dashboard. Some tips and tricks here. This was the first time we tried to merge. Is everybody familiar with Web App Builder, Experience Builder, or these brand new, the Esri guys hand up. So you've got these products, and they're drag and drop website builders for GIS. And we used the newer one, Experience Builder, to give us this nice header with buttons and logos and branding. But that was it. Everything else beneath it, we just embedded what's called a Web App Builder, a different type of product. And the first time we tried that, it came with some real useful advantages in that we can just update the app, click save, and it's immediately deployed. No need to download zip files and put them on web servers, that type of stuff. So it was nice and convenient. We had a couple of drawbacks on the export to CSV, had some issues working that way. So we're working through whether that's something we repeat again. And in the future, Experience Builder is coming along fast if you've read your Esri publications recently. So I'll blaze past this one. And final piece, if you're a data scientist or a Python person, this might ring home with you. We needed to get all the data out of the database so that we could do 2 things. One, we needed to organize it in folders by building, and then within the building, every different system, and then in those folders, every different photo that was taken with its ID. So scripted that out using ArcGIS and Python. And another use case, we had another system we wanted to load all this data into, which was very particular with its field names and types and things. So again, ETL and Python, very, very useful there. If we were to do it again, we might choose Another ETL product, FME I mentioned, is a popular one with us. Or we might just build our feature classes to match this third-party system to stock. So that's pretty much it on the GIS and solution piece. So if you're interested, we have a booth. Come ask me about any of those pieces. But back to you, Kim.
So the overall outcome was a huge success for us, even though there are things we would change. As you can see, we saved 250 hours in the field, which is extensive because when you have engineers who are doing 10 other tasks, and I'm telling them, hey, I need you to be in the field for a day, they're not really very inclined to work with me. So when I say, hey, we scheduled you for all these days, you get all these days back, it works out really well. They're excited to use it. There was a little bit of learning curve getting people who are used to pen and paper using iPad. But we found the iPad worked a lot better than trying to do the phone because you could just easier to type, you could use the pen, a lot of different things that we could do, and it just made it simple. It also gave everyone accountability. They had their iPad out, they're walking through, taking pictures, noting things, instead of trying to use a personal device. We also saved 500 hours of data entry. So this is 3 weeks just for our engineers and all that time for our data manager, because usually they're sitting down, going through and typing everything in, and it's a collaborative process. Here we found that they were able to go in, clean up a lot of the record, and then just come back to the engineers and say, I need you to confirm this, I need you to help with this, and just really more of a QA/QC process instead of the whole input process. So it made it a lot simpler. Everyone was a lot more excited to work on the project. It was less time consuming for us. It was also just simpler. And it made it to where we could go through and see things, as James showed. We could see what was happening on the dashboard. We could look at it. We had a couple times where the client would log in and just be like, oh, I saw that you have this many records. This is great. You guys are clearly doing something. This made us 30% faster than what we would normally do. We have a very good grasp on the time that it takes us to go through building, as well as like planning them out. And so it made it faster. We still were able to add in 12 buildings that they didn't realize they owned. And so that made it to where it was a better environment for our client. They could just add things. There was no price increase. There was no coming back and saying, I'm not sure if I can do that. Sure, no problem. We're there. We got it done. We still finished on time. We finished the project at the end of the year. We gave them all the data, and now we're at the point where we're doing some other tweaks for them, but none of it related to this. So that made it great for us, and everybody got it done before Christmas, which was good too. So kind of what we learned, there are definitely no perfect surveys. It worked out very well for us that we could send messages while we were in the field and say, hey, this survey, we actually need to tweak that. And James and his team could tweak it, tell us, we would reload it on the iPad, and we were able to just continue working. So there was never a point where we had to stop and wait for something or find a workaround. We did work through a couple different workflows before we found what was right. This was more on the team side of things, making sure we understood what we were doing and getting the correct data in. But we have lots of improvements. We've used this on other projects, and we're going to continue using it going forward just because it makes life so much easier, and then we have a nice way of seeing all the data instead of before where it was piles of paper on someone's desk that you hope they caught everything and not just okay, well, we're flying by the seat of our pants, but this, we know it's in there. We have all the photos linked to it, and it just comes across a lot nicer. So there are a lot of things that we want to do. GIS is not my wheelhouse. I know very little about it, and so I feel like it's a constant of pinging James and his team and saying, can we do this? Can we add that? And so we're starting to grow it more and more so that our side is more efficient, as well as the information our clients are getting is something they can actually implement, because no one wants that 5,000-page report that sits on the shelf and just collects dust. They don't want to pay for that. We don't want to give them that. So it's been a lot of a game changer for us, and we're looking forward to seeing how it goes in the future.
All right. 20 minutes. Thanks all. So any questions, feel free to fire away, or like I said, we have a booth in the main room, so if you think of something between now and then.
Great
stop by. Yeah.
Question, sounds like a great project, very happy customer, and learned something in the process.
So, yes?
So you chose an open source backend for, say, Postgres,
Yep.
as opposed to using SQL SDE. Why was that?
cost, usually. The Amazon fees for Postgres are lower than running SQL Server, but really that product in particular, that database, has been around forever, and we've used it a ton of times, and we trust it. We work with SQL Server and Oracle and others, and now we work with non-relational databases as well as stores, so but it's cheaper to run Postgres. Yeah.
Did you know right away you wanted to use Survey 123? It seems like there's like, Esri has a number of apps that kind of do similar things.
Yeah, pretty much. So Survey 123, that's true, isn't it? Esri have several field collection tools, and they do different things very well. These days, we're choosing between Survey 123 and field maps, and if it comes down to how nice do you want the input form to be with the current versions of these tools. The forms are very good with Survey 123, plus we know it really well. It's been around for a while. I wouldn't be surprised if we've got a dual survey field maps solution coming out soon where you can digitize polygons easily and do those sorts of things. So up for debate with every project that we do. Yeah. Well, thanks.
I think that question's a great lead into the next presentation. Thank you very much.
Thank you.